Determine the locus of a point on a rod of length L which divides it into ratio 1:2 and slides with its ends on two perpendicular lines. Let's try to understand the problem graphically first. So we start with your Cartesian plane with the x and the y axis. So they have this, they meet at the origin O. Now it's given here that we have a rod of length L. So the rod is going to be resting on the wall, or we can say on the y-axis. So here we have the rod. The rod has a length L. It's resting on the y-axis such that if we consider a particular point on the rod, let's say this is the point, we're going to call this as point P. It's going to divide the length of the rod into ratio 1:2. Fine. To begin with, what we'll do, we'll consider that the coordinate of this particular point P, let it be h, k. Now, since the rod of length L is lying on the one of the end is lying on the x-axis, touching the y-axis, and the other end is touching the y-axis, so we can define its coordinate point. So let us suppose that the coordinate of point A, this is going to be A, 0. And the coordinate of the other end point, which is touching the y-axis, let it be denoted by B with the coordinate 0, B. Fine. Our goal will be to find out the locus of this particular point P. So how shall we proceed? First, what we'll do, we'll try to determine the coordinate of this point P by using the section formula. So we can easily use the section formula. All we have to do is take 1, multiply with A, and take 2 and multiply it with B. Fine. So this is going to give us, we have 1 times the x coordinate of A added with 2 times the x coordinate of B. So that's going to be 0 divided by the sum of the ratio. So that's 1 plus 2. This is going to be the x coordinate. Then we similarly use the same rule to find out the y coordinate. So here we have 1 multiply with the y coordinate of A, that's 0, and add it to 2 times the y coordinate of B. That's going to be B in lowercase divided by 1 plus 2. So that's going to give us, we have A over 3, comma, then we have 2B over 3. So that's going to be the coordinate of point P, or we can say the coordinate of point Q, which we have assumed that it's h, k, that's equals to A over 3, 2B over 3. So if we equate them, then we'll get h. So h will be equals to A over 3. And then we have k, so k comes out to be 2B over 3. Now, if we want to represent A in terms of h, so we have A equals to 3h, and if we want to represent B in terms of k, then B will be equals to 3k over 2. Now what we'll do, we'll consider the right angle triangle BOA. So clearly it's right angled at O. So what we can do here, we can use the Pythagoras theorem. So the Pythagorean theorem states that we have OB squared plus OA squared. So this will be equals to AB squared. Fine. Now, what's OB squared? OB squared is nothing but the y-intercept, so that's the length B, and OA squared, that's the x-intercept with value A. So here we can replace OB with B squared and OA with A squared, and this will be equals to AB squared. What's AB squared? AB is nothing but the length of the rod, and it's already given here that the rod has a length of L. This will be L squared. And we are going to replace the value of A with 3h and B with 3k over 2. Fine, let's do that. So we get 3k divided by 2 whole squared added to A squared. A will be 3 times h whole squared. So this will be equals to the length squared. We get 9 over 4 k squared added to 9h squared. This will be equals to length squared. Fine. So let's multiply throughout with 4. So we get 9k squared plus 9 times 4 is 36. We have 36h squared equals to 4 times L squared. So what we'll do, we're going to replace the value, that's the final step. We're going to replace the value of h with x and the value of k with y. So we can rewrite this as 336x squared plus 9y squared. So this will be equals to 4 times L squared, and this is going to be the equation of the locus of that particular point P, which divides the rod of length L into ratio 1:2.